We care about the speed of light being constant because speed, again, is a measure of space per time. So if speed does something weird, then that must mean, as we've emphasized already, that space and time must be doing something weird too. And in this section, we're going to describe one of the most startling implications of the constant nature of light speed, which is that there is no universal agreement on what things happen at the same time. That's where we're going. Now, to get there, let's start with the basic intuitive understanding of time, right? So over the course of many centuries, we humans have gotten pretty good at learning how to measure time. We have developed all sorts of clocks that through the ages have gotten better and better and better at measuring the time interval between one event and another with absolutely astounding accuracy. Now, having said that, we have still struggled for ages to really understand what time itself actually is. We don't yet have an answer to that question, but we do have certain basic understanding of the properties of time. For instance, we all agree that clocks that are properly functioning and properly set, all of those clocks will tick off time at the same rate, so they will all be in sync with one another. They will all agree with one another. We also generally agree that individuals that are measuring the duration of an event with properly functioning clocks will get the same answer. We all agree on how long it takes for something to happen, and we all agree, generally speaking, on what things happen at the same moment, right? Those are the basic features of time as we experience time in everyday life. Here is the thing. The constant nature of light speed says that all of that is wrong. It tells us that properly functioning, properly set clocks do not generally agree with one another. It tells us that we generally do not all agree on what happens at the same moment in time, and we generally will not all agree on how long it takes for something to happen. Now, those are some pretty striking claims. I'm not going to describe all of them right now, but we're going to take on one of them. Want to describe how it is that the constant nature of light speed ensures that different perspectives of individuals that are moving relative to each other will not agree on what events happen at the same time. And to do that, I'm going to frame it in the context of a little story. The story goes like this. Imagine that there are two warring nations, forward land and backward land, and they've just come to an agreement. They're ready to sign a treaty, except each president stipulates that he does not want to sign the treaty before the other. So the Secretary General of the United Nations needs to come up with a plan that convinces them that in the procedure that they are going to use, each president will sign at the same moment. Here's the procedure that the Secretary General comes up with. He says, look, we're going to have you both sit at opposite ends of a table. We're going to put a light bulb in the middle. We'll turn on the light bulb. When the light reaches your eye, you sign the treaty. You're equidistant from the bulb, and therefore it should take the same amount of time for the light to reach you. You should sign simultaneously. So here is the setup. The light goes off. The flash goes toward each of the two presidents, hits them, and they sign the treaty, and they are all very, very happy. Good. Now, they are all very happy that this agreement has been reached, and a few months later, they come to another agreement that they want to sign at the same moment. Except this time, both presidents want to do it a little differently. Even though they have many, many differences, each of the presidents of forward land and backward land, they both have a deep love of trains. So they want to do the treaty signing ceremony on a train that is going right across the border between forward land and backward land. So they set up the same scenario, and here they are on the train. Train is going along. There is a table again in one of the cars. The presidents are equidistant on the train from the bulb. The bulb will be turned on just as in the previous case, and when each president sees the light, he will sign the treaty. Okay, so here we go. The bulb goes off, the light flashes, goes toward each of the presidents, and they sign the treaty, and everybody on the train is again very, very happy with the result. But here's the thing. Just after they sign the treaty, word comes that the people on the platform are fighting. They're fighting because those folks from forward land claim that they have been duped. They claim that their president from forward land signed the treaty first. How could they come to that conclusion? Well, here's how it goes. So the people from forward land, they are on the platform watching this happen. And from their perspective, look what happens. When the flash goes off, the president of backward land is moving away from the flash from their perspective, so it takes longer to reach him than the president of forward land who's moving toward the flash. So let me show you that again. Watch what happens when the flash goes off. The president of forward land moves toward the flash. President of backward land moves away from the flash. The light has to travel further to reach the president of backward land than the president of forward land. It has the same speed. The speed of light is constant. So if it has to travel further, it's going to take longer to get there from the perspective of those people watching on the platform. And therefore, they claim that the two presidents did not sign at the same moment. They claim that the president of forward land signed the treaty first. Let me show you one more variation on that so you can really see the detail of what's going on. This time I'm going to draw a line where the flash takes place. There's where the flash took place. Look how far the light has to travel to reach the president of forward land versus backward land. It only has to travel this distance to reach forward land. It has to travel this distance to reach the president of backward land. Light travels at the same speed. If it has to travel further, it's going to take longer to get there. So we now have an interesting situation. Those people on the train are absolutely convinced that the two presidents signed at the same moment. Those people on the platform are just as convinced that they did not sign at the same moment. So the big question is, who is right and who is wrong? And the answer is, they are both right. The reasoning of each group of individuals is absolutely impeccable. For those on the train, the presidents are equidistant from the bulb. Bulb lights up. The light travels the same distance to each, so they sign at the same moment. Perfect reasoning. Those on the platform, they say the flash goes off, and it doesn't have to travel as far to president of forward land as it does to the president of backward land. Speed of light is constant, and therefore they do not get the flash at the same moment. That reasoning is absolutely impeccable. So what this is telling us is that the constant nature of the speed of light means that events which take place at the same time from the perspective of one group of individuals will not take place at the same time from the perspective of another group of individuals moving with respect to them. Now, this relies, of course, on the constant speed of light, because what Newton would have said is he would say the projectile, say the light, will get an additional kick from the train moving in this direction, and that additional speed will allow it to cover this distance in the same amount of time. The light going this way would have its speed diminished, and therefore it's traveling a shorter distance. And when you take those two effects into account, Newton would say both of the presidents get hit at the same time, regardless of your vantage point. But because of the constancy of the speed of light, we come to a very different conclusion. This is what's known as the relativity of simultaneity, and is one of the most startling implications of the constant nature of light speed.